Hello everyone, this is Anil here. Welcome to my YouTube channel. Today I'm going to discuss about a new application that is called the Student Management app. I've created this application to demonstrate the complete end-to-end of Docker Compose, Docker Volume, Docker Networking, and all about this Docker so far what we have discussed. Okay, I'm going to explain step by step. First, I will go through the code base, then I will show you the architecture diagram, internal networking for the Docker containers. Then I will walk through this application, Swagger APIs and all. Okay, let's get started. Let's go ahead and see. In this application, I am using four containers. One is for the backend, another next one is for the DB, another one is for the front end, and one is for the Nginx. If you see the backend, we have this Docker file and the main app folder. In the app folder, we have in the app folder we have few files like main.py, database.py, prod.py, models.py, and schema.py. These are the Python files which is going to handle this application. Let's go ahead with the main.python file. This is the main Python file to control this application. This is controlling all the fast API related services. We can see this importing the logging and the fast API services and all. And first of all, what it is doing, it is going to check the database whether it is live or not, because the first service it need to be checked is whether the database is active or not. It is trying to um, do the basic functionality to see whether this database is live or not. This is what this particular function is doing. Okay, once it is done, it will start the fast API using this. It is initially using the fast API title. It is in the title the Student Management System API. After that, it is checking all the functionalities, and it will go to the course, and it is allowing to communicate. It is giving some middleware. It is allowing to communicate with this application, that with this API endpoints. Now we have the routers. This is the student route, major student router. We will come to know about this router. It is connecting to this student router. I will come to that later. Okay. Now we have this API endpoint app.get, and it will get all the details related to this redoc. Redoc means it's a API document. And we have this slash health. It will check the basic health of the application. This is all about this main.py file. Next, we will go ahead and see the database.py. That is going to handle the entire database connectivity and all. First of all, it is initializing the database connectivity, that is a MySQL. Then it will create the database engine, and it will create the session, and it is the base declarative base. It is calling the declarative base, and from there it will invoke the DB. This is what this database.python file is doing. Let's go ahead and see what is the models.py. This is handling the schema. Schema means the database schema. And what are the function, not the functions, what are the ID, whether it is integer or primary key. It's just the schema validation. Not the validation, it's just the schema of the database. Then we have this schema.py. What it is doing, it is in our database we have different fields like name, email ID, phone number, and all. And all of these components have its own validation. Is to get phone number, there should be 10 digits, and for the email ID there should be first name, last name, @xyz.com, something like that. This is called the schema validation. We are using pydantic for the schema validation here. It is creating the first class, that is a class student. This is the base class. It is inheriting from the base model, and we are creating this class. This is the parent class. We are going to inherit this class down the line. All the um, classes which is coming down, it is going to inherit from this parent class. And we are creating student create and student update and student response, student list response, message response, and all of this different functions we used to call using this API endpoints. Okay, these are all inherited by either the base model or the student base class we have created earlier. Next, we can go ahead and see the CRUD operations. These are the CRUD operations when the API endpoints are calling for any get or put or delete. These functions are getting called, and the corresponding action will be taken against the databases. These are the get student by email ID, get student. Then we have this function to create database or create student, update the student, and delete some student from the entries. And this is the statistics. These are functions to work on the API endpoints. Whenever we use some API to update some students or delete some students, these functions will be called internally. This is all about this major Python files. Then go ahead and see the routers. I have shown you in the main.py file, Python file, there is a router is used. That router is pointing to the student.py file. What it is doing is whenever there is a student related router or API is calling, it will come and hit on this file. And here we have the router.get. It will get the response of the student, a list of students, and post if they want to post something. That posting means updating some information or putting in inserting new data. It will come here, and this is the get related to that student, and this is put again. This is delete or delete student. These are the basic API endpoints. Let's go ahead and see the Docker file for this backend. If we see the Docker file, it is a two-stage build. First, it will use this Python 3.12 slim image to create a base image. It will use the build directory, and it will create a virtual environment entirely and using this path, and copy the requirement.tsc and install all the libraries required for this application. From this, it will be creating a lightweight image. This lightweight image will be given to the runtime stage. And runtime stage, it will use the same slim image, and it will be labeling the package, that is student management system, and description it is giving. It is running the adding group, and it is work directory setting as app. Now it is copy from the build directory to the environment dot opt It is setting the path, that is the path, Python path settings, and copy the app directory to the Docker file system. Then this is the app user, and it is exposing the port 8000, and it is running this application using UECon and exposing the port 8000. This is what this backend Docker file is doing. Next comes the DB. This is the initialization script for the database. It is initializing this database, and it is inserting some basic details. Next comes the front end. Front end, you have this app.js, index.html, and style.css. Index.html is giving the front end, and the app.js and style.css is supporting files for this HTML page to render all the details, and it will function as a helper function for all the API endpoints and all. If you see the Docker file, this is using Nginx 1.27 Alpine lightweight image. From there, it is copying the index.html, style.cs, and app.js file into the HTML folder of Nginx. From there, it is exposing this port 80, and it will do the basic health check and serving is from there. Let's go ahead and see this Nginx service. Nginx we are using Nginx 1.27 Alpine, the same base image we are using, and it is exposing to port number 80, and it is copying the nginx.conf into this nginx directory. And let's see the nginx, what is nginx.conf. Here we have few worker process settings, and then we have the upstream pools and the main server block. Okay, upstream worker process, what is it doing? It is setting up the error log, PID, events, and it is serving the HTTP from where it has to give the HTTP default type and log format, how it will be access log, and all the zip files and all, client max, body size and all it is giving. Then come the upstream pools. We have the two upstream pools: upstream backend pool that is opened on 8000. Whenever there is a request coming to open the backend, it is routing to the 8000 port, and the front end, it is opening on the port 80. Next comes our server, that is a main server hook. If it is something like a slash API, it will go to the backend pool. If it is something to slash, that is a root, that will go to the front end. This is listening into port 80. This is server underscore name space underscore mean. This is to invoke any server related. And then comes the Nginx health check. That is the slash health. It will give the health of the Nginx services. This is the VNV file. Then the last file is Docker Compose. Docker Compose, it is we have 4 different containers. One is for the MySQL. MySQL is the first container. It has to be up and running for the remaining services to start working. This is a MySQL database container related configuration. Next comes the fast API backend. Then comes the static frontend. Then come to the Nginx service proxy. Then we have the static persistent volume, that is for saying the MySQL data. Then we are using 3 different networks, that is for the student frontend network, student backend network, and student DB network. This is going to give isolation and security. This is all about all this configuration files and all. Let's go ahead and see the architecture of this application. Then we'll come back and we'll run this application. If you see the architecture, for the front end, we are using HTML, CSS, and JavaScript. Backend, we are using Python 3.12, Fast API, and SQL are coming. And for the database, we are using MySQL. And the proxy, we are using Nginx reverse proxy. And container orchestration, we are using Docker Compose version 3. These are the live endpoints. Let's go ahead and see this architecture diagram. User will come and hit on port 80. It will connect to the Nginx reverse proxy. Depend upon the request, it will either to go to the front end or to the API. If it is slash, it will go to the port 80. It will give the static front end page through Nginx. If it is slash API or any other request, it will go to the backend. The fast API and Python will serve the backend connectivity through port 8000. Then the SQL queries will go and hit the SQL DB. This data is residing in a persistent data storage controlled by the Docker container, Docker's file system. And next comes our network topology. If you see, we have 3 different network topologies, that is student DB net, student backend net, and student frontend net. This is giving isolation and security for each services. Next comes our container dependency graph. We have the DB. It is on the highest dependency to the downline services. Once the DB is up and running, then only the backend will function properly. So the backend is having the dependency with the DB, and the Nginx is having the dependency with both backend and frontend. Next comes this Docker volume persistence. This is a DB container mount point. It will be mounted on this var lib MySQL. It is stored on the host file system. And this is the API request flow. If you see the API request flow, let's zoom a little bit. From the browser, user will come and hit. It will go to the Nginx proxy. Then the Nginx proxy will give this static HTML, CSS, and JavaScript file. Once it is signed the web page, then it will give the API request either to get API students. It will request the Nginx proxy. Depend upon the request, either it will go to the backend or it will retrieve the details back. Now we are asking about the API student. It will give the get student details. It will go to the backend API. The backend fast API will route this request select start from student in the MySQL database. It will get the rows. What are the rows which we have requested? It will get the rows, get the JSON response, and send it back to the web API. If there is a request related to the post, it will be the post request. The same way, it will instead of get, it will go as a post request. It will do the pydantic data validation for post request, so that it will, if there is an error, it will throw exception. To avoid that, we will do the pydantic data validation at the fast API itself. If it is correct, if the syntax and all are correct, then it will pass to the insert into the student, insert or update or delete will go. Then once it is done, it will give the acknowledgement back to the fast API and then it back to the browser. This is same for the remaining requests as well. This is the Docker Compose network. If you see the Docker Compose, we have services, network, and volume. We have 4 different services. One is for the Nginx, that is the gateway for the application that is running on port number 80. It is exposing the port number 80 to the outside world. And the port mapping is done 8080, that is the host port, and the container port is 80. I haven't changed it. I have given the default one. This is just for the demonstration. So this is the Nginx is connected to the student front end network. Then it will go to the front end service. Then if it is not to the front end, if it is a API, then that request go to the student backend network. Then it will go and connect with the backend. If it is a backend services, definitely it has to go and connect with the student DB net and get the details from the DB. That DB data is listening in the student MySQL data in the backend volume. That's the persistent volume. These are the basic architecture of this application. Let's go ahead and spin this application and see this visual interfaces. I'm going to open the terminal. Let's open this bash so that it will work function well. Okay, to run this application, I'm going to use the detach mode. Yeah. It's still running. We can go ahead and see this Docker desktop application, whether it is created or not. Content is still getting created. This is a student management app. Just created the application, I think. Let's go ahead and see. Yeah, this is our beautiful interface. We can add student here. We can give my name, Anu at example.com age. Let's give some 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. Course computer science and grade. Okay. Street 1, 2, 3. ABC Street. Is an active student, not the student. That student has been added. Like the way we can, if you want, we can edit some user and we can delete some user. It will delete the alias user. Okay, let's start with how it will be reflected here. 10 student, 8 active and 2 inactive, and 7 courses. This is a Swagger. Let's go ahead and see the Swagger UA. Swagger UA means it's the API user interface we can use. Yeah, this is the get student. If you want to get the details of all the students, we can use it. Try it out and just execute. It will give all the details. If you want to do the C URL, you can just copy this, go to the terminal and execute this. See, this is giving all the details about that student. This is the same data which is displayed in a beautiful way when we use this web UI. This is the same data which is parsing here in the web UI. And next comes post. If you want to add in a new user, I need to try it now. I'll use instead of this one, Roshan at example.com. Let it be all the other details, Main Street. Let it be. And execute. See, it was given 201, that means success. Okay, like that we can, if you want to delete any student, we have to give the student ID. Student ID means we'll be giving some student ID. This auto populate this ID 0. Let's get some student ID. What is say student ID? Okay, let's see whether we can delete or not. Delete some user student ID. What is the student ID here? Name. ID. Okay, let's see this user with ID 2. Student ID 2. Let's try to remove this. Okay. Try student ID. Try it out. Student ID 2. Execute. Let's see the output. 200. Student Bob Smith deleted successfully. Student Bob Smith is there. This is the student ID. Let's refresh this page and see. See, Bob Smith has gone. That ID has been removed. That means the Swagger API is working fine. And this is all about this application. This all the services are running using the Docker container. And this is the documentation how we have to use this Swagger API and all. This is just a documentation. We can use what are the services available, what is this functionalities and all about this Swagger API documentation. This is all about this application using this Docker container, Docker Compose and all. If you see, let's go ahead and see the Docker container in the Docker desktop. This is the Docker desktop. This is the container. It has created 4 different containers in this application. And this is using these images. It has downloaded this MySQL image, and this is the backend Nginx and frontend image. And if you see the volume, there is a separate volume for MySQL databases. This is all about this demonstration of this application. Here I have covered all the services from which we have learned so far in the Docker, from Dockerfile, Docker Compose, Docker Network, and what else? Yeah, those are the many things we have covered, and Docker Volume, most important. All these things have been integrated on this application, and that's all. If you want, I can just go ahead and show you a few of the other commands. Like if we want to delete this container, we can use a Docker Compose down. But if you are executing using the -v command, it is going to delete the backend volume also. So be cautious about the Docker V and Docker Compose down -v if you are using that volume, specifying the volume. This is for monitoring. If you want to monitor, we can just complete log. You can get it -f. If you want to log or monitor only any one of the container, we have to give the container name also. If it is a backend or DB or Nginx, it will give only the logs related to that particular services. And these are the curl command we can execute to validate all this application. Yeah, this is all about this application. Thanks for watching this video. Have a good day. Bye.